Hi everybody. When I initially did many of the videos in this series, I decided to simplify what back-end developers do. And I thought it would help you focus on kind of the database part of the code. But now I'm thinking that I simplified some of those other bits a little bit too much, and it might lead you to do some not so great practices that you'd have to kind of undo when you get a job later on. And that's what I'd like to do in this hopefully short video, is just tell you, kind of back up a little bit and get rid of some of those bad practices, let's call them, and replace them with some not necessarily the best practices, but pretty good practices to do. So that's what I'd like to do. They might not be the best practices, and when I ran over these, or when I gave these practices to a group of back-end developers, almost all of them said they were reasonably good practices, but they always had some sort of exception, either one made of choice that because of what they were doing, they decided not to do this best practice, or just because they were lazy and they said, well, yeah, that's a good idea, but I don't really do it. But for the purpose of this class, and just kind of to get you instilled in doing things in a pretty good way, I'd like you to follow these practices. So let me first dive into the website that we will be using. So this is the one, a pretty similar one to one I've already shown you in another video, but it's just the simple UMWRC Club one. The first page, I do a database query and show what today's events are. So there's this midnight glow. Today happens to be January 1st, so there's this midnight glow flight happening and the New Year's Eve drone racing. That would be nice if those were happening. And another page that has all the events, not too many, but just a list of the events that are occurring. I have a way of adding events, and a way of doing that with a bunch of input fields here. So I can select that something's happening on the 2nd, and it's, let's say it's FPV Basics lesson. And let's say the location is the let's go. This happens to be a flight place here in Las Cruces, so you can go fly. Let me pick a time here. It's not so nice as, let's say it's, I'm just kind of scrolling around. Let's say it's 3 o'clock here in the afternoon. And the contact's me. I'll just say Ron. Shoot, sorry. I screwed up there. All right, so that got added there. All right, and there's also a join, and I don't want to take the time to do it. I was hoping to make this a short video, so let's not get into it. All right, so here are the best practices that I see. And this best practices list is just a README file in a Git repository that you can download and see them in action. So this code I'll be showing you today is something you can kind of refer to later. And the first one is code that is database specific should be in a separate file, as should be configuration code. Now here's where some of my software developer friends kind of deviated from it, because they one really hot thing of developers do now is what are called microservices. And what these are, as kind of the name implies, is really small services that you're writing. They can be in different programming languages, use different database or servers, and they kind of use message passing as a way of communicating among these services. So in this case, it may not make sense to divide the code, because you want them, because there's so many things happening, you want things to be relatively quick, and just dividing things might slow it down a bit. But for the most part, it's a good idea to separate database-specific code into a separate file. So if you change a database server, if you're moving from Postgres to MySQL, this just makes it a lot easier, or even something more drastic like moving from an SQL to a NoSQL database. This just makes life a little bit easier. So let me show you what I mean by that. So here's the kind of the old school code that you'll be seeing in almost all the videos. Again, I would want you not to use this as a model, but rather what I'll be showing you shortly. But here I intersperse code, database-specific stuff right into the routine that I'm using to render the page. So the database code is kind of interspersed throughout this initial file. And instead what I'd like you to do is divide that up. And let me show you what I mean by that. So here, this equivalent of the main index, I just am calling these functions, get a new event here, get today's events. Here's another one, get today's events. And I'm not doing any database specific stuff. Rather, I'm sticking that in a separate file, which I'm calling data PostgreSQL py. And let me just show you how to import. And I also have a configuration file here where I have the Postgres user, the password, and so on. So that's all in a configuration file rather than being in server py. So let me show you how I get those. So here's how I do the configuration. So lib.config. So lib, the reason I'm doing that is I have a directory called lib. That's right here off on the left. Sorry, I'm not, if you can see where I'm wiggling. So I have a directory called lib, and in that I have a config.py. So that's where I'm getting this lib.config from. In order to do this sort of syntax, that directory lib needs to have an __init __.py file, and that one can be empty. So here I have the init py file, and you can see it's empty, but just having that enables me to do this syntax of lib.config. So that's right up here. Now my database code I'm importing in a slightly different way. I'm putting an alias of PG. So every function I'm going to use will have a PG, as you see here. So so this new event is going to be defined in that data PostgreSQL file. So that's what I mean by dividing the code up. So you see there's nothing specific here. Everything's in this data Postgres file. I have one connect to Postgres in my code, anywhere in my code, and one code thing that handles all the query execution, and then I have these functions that relate back to it. So that's what I would like you to do, to have both a config file and all your database code in one file. So that's best practice number 1. 2, use try except blocks. This is shown in almost all the videos, but I just want you to do, a lot of times we're in a hurry and we tend to ignore it, so please use try except, and I'll show you even a better practice than the one in other videos. And let me get to my data Postgres file for that. So here I'm actually getting the exception, except as E. So that's one thing I'd like you to do, is to do that, and then you can print it and get a fairly good idea of what's wrong. And I do that even here, and every time I have an except, I do except as E and I print it. And I also percolate up that something bad happened. So I do these return nones, which are not present in my other code that I give throughout the series. And then what I do with that is I catch that. I say if, so I try to get a new event, but if I don't get one, if something went wrong, I'm going to return my little whoops template. And let me just show you what that looks like. So I'm going to go and config here. I'm going to change the user to something that doesn't exist, club222, and then go this away to get my RC club again. And now I'm going to go home, and I get that whoops page. Whoops, something went wrong. The development team is extremely sorry. So how I accomplish that, well, let me get back to data here, is if something does go wrong and I do so in the except block, I return none here, indicating something went wrong. Perhaps I could have returned that error as well. And then I just percolate that up. So when I do a test here in server py, so if the result equals none, then I generate that whoops template. These are things that I don't do, or I've been really lax at doing, and I'm really feel bad that I'm kind of making my bad habits live in a lot of the people who are taking this 350 class. So I just want to point out that you really should be disposing of old cursors, especially as soon as possible, and you should also close the connections, but try to keep those open as long as possible as well. So these are my bad habits that I think are rubbing off on students, and I don't feel really happy about that situation. So let me show you what I mean by that, and that's in this data PostgreSQL file. And here when I execute, let me actually do when I execute the query, which is here. So I'm opening a cursor. Right there, I get the cursor. And then as soon as I get results back, I'm closing the cursor. So I'm closing the cursor as soon as possible. I grab results, close the cursor. Every time I open the cursor, grab stuff, close the cursor. That's kind of the correct way as fast as possible. So we have really simple queries here, and this doesn't happen. It's hard to illustrate this next thing, but you are trying to keep the connection open as long as possible. But in our case, since we have simple things, we just open it, we do our business that we need to do here with that connection, and then we close it. So that's the correct way of doing stuff there. I don't think I need to elaborate anymore, other than, please do what I say now versus what I've been demoing for the other videos. All right. The next one is roll back or commit frequently. Let me show you that one. All right. So here's that execute query again. I execute the query. If everything looks good, I commit immediately. If it doesn't look good, if I get an exception, I roll back. That's all that we need to do. A lot of times people, this is what happens. If they do an insert statement, it looks fantastic. They type the exact same statement in when they're in the PostgreSQL at their terminal level, so they know that works, but nothing ever gets inserted. That's a common symptom of you never really did that con commit. So make sure you do the con commit and do these relatively soon after you do the executes, as soon as possible. This one will save you lots of headaches and will save you lots of embarrassments in your job because it prevents one type of malicious exploit called SQL injection, and this wording is exactly from the PostgreSQL documentation. Never, never, never use Python string concatenation or string parameter interpolation to pass variables to an SQL query string, not even if at gunpoint. And let me just demo that or show you what I mean by that here. All right, so here's a common situation. So we define a variable user equals and. So here we're getting a query together. Let's say this was actually passed in from a web page. So what we might want to do is we're trying to find a user with that name. So here we do that Python interpolation. This is not the way to go. So this is a bad practice. I hate to use such an awful word like bad, but it is. This also is not a good way to go. So here I'm just doing that concatenation with these pluses. Do not do this. Both these lead to a possibility of SQL injection. I have a video on this later, but I'm just kind of stressing this point because it's a point that needs to be stressed, I guess. Even if they mentioned the gunpoint business, it's an important point. This one also doesn't, it looks better, but it's the same problem. In fact, you're using this interpolation. This is the right way, where we're using the PostgreSQL itself, the cursor object, to do the replacement. So it's here, the only difference is instead of that Python %, we're using the comma, but that's the way to go. An even better way I like, and let me just show you that, is I can say query equals, so I'm letting the cursor object here make that replacement, and then I can execute it. So really it's kind of odd because this is a single step versus the two-step, but what this enables me to do is if I ever have any questions about that query, I can print it and see what it looks like. So that's another little handy feature there. But it's that idea of never ever use Python interpolation or concatenation. Never, never, never store passwords or password-like data in the clear. These are user passwords, so you have some sort of register for your account, and you're going to stash that stuff in the database, and this is extremely important. What happens is, this is covered in another video, and people do well in that video to do it, and then they tend to forget that idea later on in the course or later on in other, when they get a job. So, they do it when they have to, and then they forget about it. So here I'm just trying to stress it, even though it is covered again. And here's what I mean by that. So let me show you, that would be in data PostgreSQL. Here I'm adding a member here, and that member has a password. And instead of, and I say never store passwords in the clear. So here's what I'm doing. I'm hashing that password. It's a one-way thing to do. It's covered in a video, but this is the correct way. Don't store passwords in the clear, hash them. This one here we don't cover at all in this course, but in other courses you will be doing, or in other work probably you will be working with credit cards, especially if you're a small company. Never just let some other payment gateway or vendor handle credit cards. They're a big pain, and you don't want to lose users, one of your customers' credit cards information. So use a payment gateway or a vendor. And if you're a large company, you really want to check out what the best practices are. This is, credit cards are really not a thing you want to mess with. It's like, you don't want to stick your hand in some 120 volt, circuit without thinking about it. And finally, this last one is when you create passwords for Postgres users, always use real passwords versus something like password or 12345. And this I'm guilty of violating, or I have been, and I've been getting better. I'm kind of a reformed bad password person. And, I see this time and time again with developers when they're working. And this is what I mean by that. So you're developing something, and you need to create a user for your database that's going to be responsible for inserting and doing selections and stuff. And you give it some easy password, because who cares? I mean, you're not going to, it's not a big deal. You're just developing this stuff. It's not any security problem. So you might say, oh, Postgres password is password, or 1234. And the problem with that is you're in development here, but when you go into production, there is that risk that password will stay in that code in the production server. And that's not a good thing. So it's much better to kind of get in the habit of using, this isn't the best password, but at least it's better than 12345. It's much better to start and just make it a habit to, okay, I'm going to make a real password here. So that's pretty much it. I'm hoping it was relatively short, and I'm hoping it will help you become better developers and not do what I've been showing in some other videos. So anything you see in the video that violates one of these, you want to switch to this method. And let me just show you those methods again. This one here is not shown in other videos. You need to separate those that code out. Try and accept is in other videos, but I showed you some better techniques in this one. These were my tremendous bad habits, so I violate these all over the place in the videos, and I'd like you to not do that. I want you to fix these problems. Rollback and commit, they were in other videos. Just continue those practices. This was in other videos, but people tend to forget them. So it's a good idea to do it. This one here, again, people seem to forget, and they run into problems later on in life. So please remember that one. And these are mentioned in other videos. This credit card information makes perfect sense. Just if possible, don't deal with credit cards. Just deal with some vendor that can do it for you. And finally, this one about creating good passwords for the Postgres users. So that's it. I hope this was helpful to you. I'll see you in another video.